Great. Thanks, Alex. Thanks, everyone, for joining today. So yeah, as Alex said, this is going to be a 2-hour training session focused on building GraphQL APIs using the Neo4j GraphQL library. And we will also be using Neo4j Aura, which is Neo4j's hosted cloud service. The slides are available at dev.neo4j.com/nov-GraphQL. That's just a link to the Google slides that I'm presenting here. I do suggest that you open these up and have them open while we're going through this workshop. There are some links and code snippets that you want to be able to copy and paste from the slides. That will be helpful. So my name is Will. I work on the developer relations team at Neo4j. What that means is it's basically my job to spend time with developers and help them build applications with Neo4j and other technologies. So a lot of times this dives into the intersection of Neo4j and different technologies, helping developers build cool things. I also co-host the graphstuff.fm podcast. So if you're interested in graph technology and you like podcasts, that might be a good thing to check out. Also, I guess probably the best way to get a hold of me online is on Twitter. I've got my Twitter handle and my website where I have a blog and newsletter as well. So let's talk a little bit about Neo4j before we get started. This workshop doesn't focus on just Neo4j. It's okay if you're new to Neo4j. If this is a new concept, that's fine. We're going to spend a lot of our time working with GraphQL, but I do want to talk a little bit about Neo4j and some of the interesting aspects of Neo4j, some of the tooling, and specifically the Cipher query language that we'll be using a little bit before we get started. So Neo4j is a graph database. You may be familiar with other databases like relational databases or document databases. With graph databases like Neo4j, the data model is a graph instead of tables or documents. So what this means when we say a graph, we're talking about the data structure graph. So nodes, these are the entities, the objects in my data, and relationships connect nodes. So that's the basic model that we're working with. We call this the property graph data model because we can store arbitrary key value pair properties on nodes. We'll take a look at what that looks like in a minute. And then we use a query language called Cipher to work with data in Neo4j. Cipher, you can think of Cipher as, I guess, kind of like SQL, but for graphs. So it's a query language very much designed for working with graph data. You can see an example of Cipher in the upper right on the screen here, where we're matching on something to do with addresses in New York and officers and entities. This query, this comes from the offshore leaks or the Pandora Papers or Panama Papers investigation. This was a data journalism investigation where the ICIJ, the International Consortium of Investigative Journalists, got a hold of lots of leaked data on offshore corporate registries, and they used Neo4j to make sense of a lot of the deeply connected ownership structure in a lot of these offshore jurisdictions. So what's going on here in this example query is we're saying match, so find some pattern that exists in the graph, then we draw this sort of ASCII art notation to represent the pattern that we're looking for. So we draw nodes in parentheses. So we're saying find an address node where the address property on this node contains New York. So find all the addresses in New York, then traverse this incoming registered address relationship to find officers connected to those addresses. So find all of the officers in New York, and then traverse out to these entity nodes. So those are legal entities. This is basically saying find everyone in the offshore leaks Pandora Papers data set who has an address in New York and find what offshore legal entities they're connected to. So you can see how powerful this can be just working with these sort of visual graph patterns in the query language. So we'll work a little bit with Cipher today. A lot of what we're going to be focusing on is the GraphQL piece, not so much the Cipher piece, but we will touch on Cipher a little bit. So wanted to talk about that a little bit. So there are lots of interesting implications of working with data as a graph. Graph databases have different performance optimizations. So Neo4j is optimized for traversing the graph. So lots of different and really interesting things we can do with graph databases that we can't necessarily do with other technologies. And of course, Neo4j at the core level is a database, but really there's this whole platform around the core database that enables us to work with lots of different technologies, depending on what we're trying to accomplish, right? I think this chart is nice because it shows us kind of this spectrum where we're off on the right, more interested in analytics, data science, machine learning type things. On the left, we're working on building more transactional operational applications where we're building like an API application that is maybe serving as the backend for a social media site, something like that. And this is kind of in today's workshop where we're going to be more to the left of this chart where we're focused on what do I need to do to build a GraphQL API to sort of serve as the backend for my application. Great. So we have 2 hours, just under 2 hours. And this course is designed in 4 modules. So we'll start off talking about GraphQL. So we're all on the same page about what is GraphQL, how do we use it, some of the common GraphQL tooling. We'll take a look at how to write GraphQL queries against a sample GraphQL API. Then we'll talk about how do we build GraphQL APIs backed by Neo4j using the Neo4j GraphQL library. Neo4j GraphQL library is a Node.js, so JavaScript library for building Node.js GraphQL APIs. We don't need to worry about setting up a local environment for the workshop. We're going to use Neo4j Aura, which I mentioned earlier. So in a minute, we're all going to spin up Neo4j Aura instances that will be private to us that we'll use. And then for running the Node.js GraphQL API application code, we'll be using Codesandbox. So Codesandbox allows us to edit and run code in the browser without having to set up a local environment. And each of these modules will have a starting point. So we'll have a specific Codesandbox link that's like the starting point for the module, and then we'll kind of work through some exercises. You may need to add some code to the Codesandbox or maybe write some GraphQL queries to work with it. Then after we introduce the Neo4j GraphQL library, we will take a look at adding custom logic with Cipher and a couple of ways to add custom logic to our GraphQL API. And then finally, we take a look at authorization and how we can add authorization rules to our API to protect certain data points and enforce authorization rules that are specific to our domain. We'll be building a API for a online bookstore. So you can think of the kind of like authorization and custom logic problems we might have to address there. There's some resources here, specifically the slides. So dev.neo4j.com/nov-GraphQL will take you to this Google slide deck. And again, I suggest to have that open as we're going through things. There will be some links and some code samples as you work through the exercises that you'll want to have available to copy out of the slides. That might be the easiest thing to do. And then some other resources, the docs for the Neo4j GraphQL library will definitely come in handy. There's also a landing page that has links to some other resources as well. There's also a longer self-paced version of this training on Graph Academy that goes into a lot more detail, things that we won't have time to cover today. And then also, I guess it's important to point out today that we're focused on the backend piece of our application. So building the GraphQL API, working with the database. We're not going to talk about how to build, say, like a front-end application that is a client of the GraphQL API, how to incorporate GraphQL into my web application. We're not going to cover that today, but there is a starter project for what's called Grand Stack, which is GraphQL, React, Apollo, Neo4j database. There is a starter project that you can get up and running that shows how all of the pieces fit together in the context of a full stack application. So that's a good resource if you're interested in more of the full stack piece as well. Great, so let's start by talking about GraphQL. So what is GraphQL? Well, GraphQL, I guess fundamentally, I think of it as an API query language and really a runtime for fulfilling these requests against an API. So what do we mean by that? Well, with GraphQL, we have a strict type system. So we define the data that's available in the GraphQL API, what types we have, what fields exist on those types, and how those types are connected. This is the graph piece of GraphQL, which talks about how these types are connected. So for example, we may have a field on a type that is a relationship to another type. So if we're talking about blog posts have an author, that's a relationship, a connection in the graph. Then at query time, clients of the GraphQL API are free to traverse this data graph that's been specified by the GraphQL type definitions and ask for the data that the client is interested in. Oftentimes, this is like rendering a view in an application. The application knows exactly what data it needs to render that view, nothing more, nothing less, and that's exactly what comes back in the request. Let's talk about a few important concepts in the world of GraphQL. The first is GraphQL type definitions. So type definitions are important because they define what data is available in the API, the schema for the API. We also specify the entry points for the API in type definitions in these special types called the query type, or the mutation type, or the subscription type. So queries, these are like read operations. Mutations are write operations. And then subscriptions, this is like GraphQL's pub sub functionality that we can subscribe to events. We're going to talk about mutations today and queries. We're not going to touch on subscriptions today. But type definitions are very important because they basically are defining the domain, defining what data it is we're actually working with in our API. There are a few ways to create GraphQL type definitions, but I think the most common is using the GraphQL schema definition language, or SDL. SDL, this is nice. It's language agnostic, which means that we can write our type definitions and share them with different implementations of our API. So we can also define these programmatically. but that is often done using whatever GraphQL implementation we are working with. So we'll use SDL to define our GraphQL type definitions. Then we have the concept of a GraphQL operation. So this can be like a query or a mutation. And each one of these operations has a specific entry point, and the entry point is a field on, in our case, either the query or the mutation type. And we have optional arguments as well that we can pass to the entry point in this case, which is the movies query field. So here we're passing a where argument that is filtering for movies with the title "A River Runs Through It." Then we have a selection set in the rest of our GraphQL operation. And the selection set, I guess there's two important things going on in the selection set. One, you can think of the selection set as a traversal through the data graph. So you can see we're creating this kind of nested structure here where we are traversing, in this case, from the movie to here, like the directors of the movie, and then other movies that they directed, and so on. So that's one thing we're doing with this nested structure in the selection set, is sort of traversing the data graph. Then the other important thing we're doing in the selection set is specifying the fields to be returned. So for example, for movie, we're returning the title. There may be other data that we have about the movie. So a movie has an ID, maybe a budget, like a URL for the poster image, all these kinds of things. But in this query, we're only going to return the title. And similar for actors. Actors may have a bio, they may have like a link to their IMDb profile or something like that, but we're only returning the name of the actor. Notice that we also can pass arguments to fields in our selection set. So we send, in this case, a query is our GraphQL operation. We send this to the API application, and the response comes back, in this case, a JSON document. And the shape of the JSON document matches the shape of our query. So we only get back exactly the data that we've specified in the selection set. Okay, so we've talked about how to construct the type definitions for the API, how to write GraphQL operations, the idea of the selection set and the entry points to the API. What about actually resolving this data against the backend? How do we approach this? Well, this is where resolver functions come in. Now, we're not going to do too much with resolver functions today because the Neo4j GraphQL library that we'll be using generates these for us and takes care of most of this work for us. But resolver functions are an important concept, I think, to understand and how that fits into implementing GraphQL APIs. So resolver functions, these are functions where the logic for actually going out to the data layer, and this could be to a database, this could be wrapping another API. GraphQL is data layer agnostic, so we can really build a GraphQL API on top of anything. So the resolver functions are where the logic for going out to that data layer live. In this case, this example that we have here comes from an application for a conference. So we have sessions at a conference. Sessions are in a room, they have a theme, and then we have recommended sessions. So like if you enjoyed this conference session, here are some others you might be interested in, that kind of thing. And if we see what's going on here, we're using a like database ORM type API in this case that is injected into this context object. So we're injecting like a database ORM, some way to query our database, injecting that into each resolver function, and then calling out to that database ORM to fetch data for that field. So starting off, we start off with the session query fields, and that takes a search term. And then we're going to the database and saying find sessions that match this search term. So that comes back, but then if we ask for the room, well, now we need to go back to the database and find, okay, well, what is the room that this session is in? Similar for theme, and then similar for recommended. So you can see here that we may be going back to our database multiple times with this approach for one GraphQL request. And that's not ideal, because that is going to introduce a lot of overhead going back and forth, making multiple requests to the database just to fulfill a single GraphQL request. This is a common problem that comes up in GraphQL called the N+1 query problem. And this is kind of a result of the nested way that these resolver functions are called. The Neo4j GraphQL library addresses this N+1 query problem by generating a single database query for any arbitrary GraphQL request. So we don't have this problem with the Neo4j GraphQL library, and there are other ways to solve this, but I think this is an important illustration of this N+1 query problem that comes up. So we want to be able to not have to make multiple requests to the backend when we are building our GraphQL API. So something to think about. Okay, let's talk about some of the common benefits of using GraphQL. I think some of these we've touched on, we've inferred. We've talked about this idea of overfetching and underfetching. So we only want to send the data that the client is requesting, and the client, by being able to traverse this data graph, is able to request everything the client needs to render the view of an application in a single request. So those are big advantages. I think also this bullet point, simplify data fetching with component-based data interactions. I think this is one also that is really relevant for developers. It's very nice to be able to, let's say, attach a GraphQL query to like a React component, for example, and we know exactly what data is needed to render that component. So being able to sort of componentize your data fetching in the front end is quite nice. There are lots of GraphQL tooling that's built around GraphQL, and specifically this introspection feature of GraphQL. Introspection means that we can query a GraphQL API for its type system, basically, and go to an already running GraphQL API and say, hey, what data do you have available? And then use that to generate tooling such as autocomplete or syntax checking, these kinds of things that can be big boosts to developer productivity. Now, there are, of course, some challenges that come up when building GraphQL APIs. GraphQL is not a silver bullet that's going to fix all of our problems, of course. I think a lot of the issues come about from well understood things from the REST world that don't necessarily apply in the GraphQL world. So these are things like HTTP status codes that are done a bit differently, error handling and caching. These are all handled a bit differently in the GraphQL world from what we may be familiar with in the REST world. Exposing arbitrary complexity to the client is something to think about as well. So if the client is free to request any arbitrary GraphQL request, how do we make sure that we're addressing performance considerations, the N+1 query problem that we talked about. So making sure that we're not making multiple requests to the data layer, and then query costing and rate limiting. So again, if the client is free to request kind of arbitrarily complex operations, how do I think about that in terms of rate limiting where I may want to make sure that someone is not exhausting the resources that, that we're granting them. Now, tooling and best practices have come about to address all of the things mentioned here, but it's just important that these are some of the things that that can come up. So things to think about. I mentioned earlier some tooling that exists in the GraphQL world. We will be using GraphQL Playground in this workshop. So GraphQL Playground is an in-browser tool that lets us explore the documentation for a GraphQL API and then to write queries. And again, we have nice autocomplete so we can make sure that we are requesting data that is actually available in the API and then view the results. So there are other similar tools out there like Graphql and Apollo Studio that have similar functionality, but we're going to be using Playground today. Okay, great. So let's take a look at a already built and running GraphQL API. So this will be a little hands-on exercise for us. Go ahead and open this movies.neo4j-graphql.com URL. This will open GraphQL Playground for us in our browser. You may not see this query. You may have something like this, but basically the way this works is we can click on the Docs tab on the right and explore the query entry points. We also have mutations here, more just for illustrative purposes. None of these mutations should work. I think the user that this is connected to doesn't have write operations. So you'll see an error if you do any mutations, but you should be able to run any query operations. So what we want to do is let's pause for a few minutes and give folks time to open up GraphQL Playground, explore the Docs tab, explore the data that is available, and then let's write some GraphQL queries. So GraphQL queries go on the left side here, and you can see we get autocomplete as we are typing, which is quite nice. You can do control space will bring up more autocomplete. So here, let's give the first 10 movies by title. What did we do wrong there? Movies, title. Here we go. So here's a few options for us to run, but really the point is to take a few minutes to get familiar with the tooling. So we'll pause for a few minutes, give everyone a chance to open up GraphQL Playground, run these queries, see what results you get, and try to add some additional fields, try to use the control space autocomplete. Is there a question that you have of this movie's data? So we have data about movies, actors, directors, and then some user reviews. Great, so I will pause here for a couple minutes just to give us a chance to work through this, and definitely as you have questions or if you get stuck, definitely ask in the chat, but we'll pause for just a couple minutes to work through this.
Cool. Maybe we can answer one or two questions from chat in the meantime. I got one that might be interesting. That's from Mustafa, and he wants to know if GraphQL Schema Federation is supported.
Yeah, so GraphQL Federation is sort of a way, I guess, to stitch together multiple GraphQL APIs into a single unified API. Kind of think of it as like microservices for GraphQL, essentially. And there's various tooling to do this. I think Apollo's implementation of Federation is the most popular currently. I believe so. I think what you can do is basically use, and we haven't started talking about the Neo4j GraphQL library, but we'll talk about that in a minute. Basically, what you get with the Neo4j GraphQL library is an executable schema object, which you can generate through the Neo4j GraphQL library, and can then use that schema object in GraphQL, either schema stitching or Federation as well. So that should work for you if you're using schema generated from the Neo4j GraphQL library.
Okay, cool. I think that's what we have for now. But if you talk about this, what the GraphQL library does and does not, and can and can't do, I guess we go into that a little bit later. Then I guess we cover that then. Yep, I think that's what we had.
Cool, great. Well, yeah, let's press on here. Hopefully everyone had a chance to familiarize themselves with GraphQL Playground a little bit and write some queries against our movies API. Let's take a look at the sample ones we had here. So first 10 movies, title, actors, and name. So we see here, we can see that we have options for our movie entry point by looking at the docs. There's a where argument and an options argument. Movie options, which we can click on here, see exactly what that is, and we can see that we have sort, limit, and offset. So we want just 10 movies. So we're going to say options and limit 10. And now we just get 10 movies. And then we can add fields here. So I think our example is looking at, oh yeah, the actors. And then again, we can either look in to see that movie type is connected to actors and see the field available here. Or we can just do kind of command space tab complete. Still, which is quite nice. Cool. And our other query is filtering for specific director. So then we use the where option, where argument on movie. So here we can see different ways that we can filter for movies. So we'll talk about where these filtering arguments are coming from when we start talking about the Neo4j GraphQL library. I guess this spoiler alert, this API was built using the Neo4j GraphQL library and a lot of the generated there. So filtering, for example, we'll talk about where exactly that comes from. But one of the options we have here is, in this case, we're looking at directors. So directors, where, so we can filter by director name. So let's do that. Directors, where name, I think it was Robert Redford we're looking. and they want to know what movies he directed. And, oh, and also grab the plot of those movies. Cool. So there's our GraphQL queries from the first exercise. So we've talked about what is GraphQL. We've talked about some of the advantages for using GraphQL, some of the disadvantages, some of the common issues that come up. We talked about the basic approach for building GraphQL APIs, where we define our GraphQL type definitions. Then we define some resolvers that specify how to actually fetch data from the data layer. So now let's take a look at how do we build a GraphQL API using the Neo4j GraphQL library. And the first thing we want to do is create a Neo4j Aura instance. So I mentioned earlier, we're not going to worry about setting up a local development environment. We're going to use Neo4j Aura, and we're going to use Codesandbox, which will allow us to build an API that talks to our Aura instance. So if you haven't signed up for Aura, we're going to do that now. Alex, I think, pasted a link in there that will take us to the Aura sign up page. We can sign in with Google or create an account with email. And then we're going to create a free tier database. So one thing that's nice about Aura is we can create databases that are private to us, that run in the cloud, and are sitting around for us forever, that we don't have to put in a credit card and pay for, which is quite nice. So if you've used Neo4j Sandbox before, Sandbox is nice. It gives us these private hosted Neo4j instances, but they only sit around for a few days and then they go away. Aura Free is nice because those databases we can keep running as long as we need them, which is super nice for hobby projects, side projects, those kind of things. And then of course we can pay to scale our database up for real projects that we're working on. So let's go ahead and start a Neo4j Aura instance. So I'm going to go to dev.neo4j.com/Neo4j-Aura. And I'm going to click on Start Free to sign in. Oh, I guess I was already signed in. If you're not signed in, if you haven't registered, you'll see a sign in with Google or create an account button. And then if it's your first time signing in, you'll be prompted to create a database. So you'll see a screen that looks like this. And we have two options here. There's AuraDB Free or AuraDB Professional. AuraDB Free is good for today. We can start this up without having to put in a credit card or pay for anything. Professional tier, this is good when we have a real project that we want to build and we want to scale the size of our database. But AuraDB Free is good for today. I'm going to call this Neo4j GraphQL Workshop. We can choose different regions. I'll just choose Belgium. That looks fine. And then we have two options. We can either start with an example data set or create our own data. Let's select this one, create your own data in a blank database. It's okay if you already started it and you have the movies data, that's fine too. And it gives me a password. So I'm going to copy this password and save it somewhere. You will need this password later, so be sure to copy and save that somewhere. And then we'll see a screen like this, which just says, hey, we're starting up your database, we're provisioning it. It'll take a minute or two. So we'll pause there for a minute to give everyone a chance to spin up your Aura DB free tier instance. Basically, when you get to this view that says your database is starting up, then you're good to go, and we'll move on. So we'll pause for just a minute or two to give folks a chance to start up your Aura DB instance.
Cool. Thanks, Will. No immediate questions for now, but type your questions in chat. We try to answer them either directly in chat, or we read them out in these little breaks segments, which we have throughout the whole course of the workshop. So yeah, it's your chance for getting those questions answered. Nothing came up really in the meantime. I hope you all can get your Aura DB free instance going. Maybe you have already done so to prepare for this workshop. Yeah.
Cool, great. Well, let's move on then. So hopefully everyone has their Aura DB instance provisioned, and now we're ready to talk about the Neo4j GraphQL library and start building our API. So we said earlier that the Neo4j GraphQL library is a JavaScript Node.js library for building GraphQL APIs backed by Neo4j. So we're talking very much about building this API layer that sits between the database and our client, which could be a mobile app, could be a web application, whatever it is. This is very much the case where we want to build that API layer. We're not so much talking about querying the database directly with GraphQL. GraphQL is not a database query language. Really, it's working for querying APIs from the client. So that's fundamentally what the Neo4j GraphQL library is there to do. If we think about what are the goals of the Neo4j GraphQL library, what are the sort of the main reasons you may want to use it? Well, the first is this idea of GraphQL first development, which is basically this idea that our GraphQL type definitions can drive not only the database data model, but also the API schema as well. So we're not maintaining two separate schemas for our API and for our database. That is driven from GraphQL type definitions. These GraphQL type definitions are then augmented as the schema is generated by the Neo4j GraphQL library. And what this means is basically that the library is adding query and mutation types. So entry points, by default, a create, read, update, and delete operation for each type defined in the type defs. That's, of course, configurable. And then adding a bunch of arguments, things like ordering, pagination, filtering. We saw some of that in the example movies GraphQL API, and then adding things like date time, spatial types, and that are natively supported by the database. Then at query time, every arbitrary GraphQL operation is translated into a single database request. In this case, translating GraphQL into Cipher. And this is really a huge benefit for a couple of reasons. One is this performance in +1 query problem aspect that we talked about earlier, where we were generating multiple round trip queries to the data layer for one GraphQL operation. By generating a single database query, that n+1 problem goes away. We send a single Cipher query to the database then figures out how to optimize that. Database is very good for that. Oftentimes in GraphQL, we're constructing these nested operations, which are really traversal through the data graph. So this is something that graph databases in Neo4j are very good at. The other benefit we get from generating a single database query from a GraphQL request is that we don't have to write that logic as developers. So we don't have to implement any of those resolver functions. This is a huge boost for us in that essentially we write GraphQL type definitions and we have all of the CRUD operations handled for us sort of automatically by using the library, which is quite nice. So that's sort of the create, read, update, delete, the CRUD operations. What about custom logic? How do we add custom logic to our API application? There's a few ways to do that. The most powerful way, though, is using what's called the Cipher GraphQL schema directive. Schema directives in GraphQL, these are GraphQL's like built-in extension mechanism. So anytime I have a schema directive that's indicating that there's some custom logic that should happen on the server. In this case, the Cipher schema directive allows us to attach a Cipher query to a field in our GraphQL schema where the logic is then defined with a Cipher query. So in this case, this example on the screen, we have a recommended field that is returning a list of businesses. So this is like for a business reviews application. If I'm searching for businesses, here are other businesses you might be interested in. And in this case, a Cipher query looking at users who wrote reviews of this business. What are other businesses they're reviewing? Those might be a good recommendation. So kind of a simple collaborative filtering recommendation query here. So this is a super powerful feature of the Neo4j GraphQL library, this idea of the Cipher schema directive for attaching Cipher queries. Let's look at a quick start for how we would build a GraphQL API using the Neo4j GraphQL library. We don't need to run this locally. We'll switch over to a Codesandbox that has this environment set up for us. But the way we would start off is basically by installing the Neo4j GraphQL library and its dependencies, the GraphQL implementation, and Neo4j driver. So Neo4j driver, this is the Neo4j JavaScript driver, which allows us to send queries to Neo4j. And then in this case, we're using Apollo server, which is a JavaScript GraphQL server implementation. There are other approaches, other libraries out there that we could use, but Apollo server is quite nice for handling the networking layer for serving our GraphQL API. Then here's the basic code that we need. We need to pull in our Neo4j GraphQL class from the Neo4j GraphQL library and the Neo4j driver and Apollo server. Then we define some type definitions. In this case, we have movies and genres. Then we create a driver, a Neo4j driver instance that is pointed at our database. We're going to be using Neo4j Aura. In this case, this is just pointed at a locally running instance. Then we pass our type definitions and this driver instance to the constructor for the Neo4j GraphQL library, and we get back a Neo4j GraphQL schema object, which we can then pass to Apollo server and start up our GraphQL API. And then run that index.js file, and we have a GraphQL API up and running. So that's the basic idea. Let's take a look at a slightly more complicated model than just movies and genres. And this is what we're going to be building now for the rest of the workshop, which is API for an online bookstore. So the first thing we do, I think, when we start to think about how do we translate business requirements to a graph model. So in this case, someone has already gone through this exercise for us to come up with the model, but I think it's interesting to talk about how we arrive here anyway. And basically what we do is we take our business requirements. So in this case, it's I need to be able to search for books. I need to be able to buy a book. I need to be able to write a review of a book that I've purchased. These kinds of business requirements for a bookstore. The first thing we do is kind of ask ourselves, well, what are the entities in our domain? These become nodes. Then we think of, okay, well, how are those nodes connected? These become relationships. We think of what are the attributes of the entities? Those become properties. Then we think, how do I answer my business requirement questions by traversing the graph? So for example, if it's I want to search for books by topic or subject, well, it might be I want to be able to search for subject nodes and then traverse to the books that they're connected to, and that satisfies one of my business requirements. I sort of go through my list, and if I can think of a traversal through the graph that answers my question, then that requirement is satisfied. I can move on. If not, then I need to sort of iterate on my model. So that's basically the general idea of this data modeling process that we go through. So let's jump into Codesandbox and set up our environment. So there's a specific link here that we're all going to use. So each one of these modules has a starting point for a specific Codesandbox, which has some skeleton code already put together for us. So if you have the slides open, and maybe Alex can post this in the chat. This is slide 31 that says open this Codesandbox link. And that link is pulling the code from GitHub, so you can find all of the code on GitHub, but it's pulling it into this Codesandbox environment. So Codesandbox is quite nice because it allows us to run JavaScript code, and in this case, even Node.js code in the browser. So we have over here, we have a few files that we're working with. So you should see something like this. And we can edit these. And then the running application is on the right side of the screen. In this case, we have GraphQL Playground and some things logged to the console. So initially, we're starting off with this skeleton code for a Neo4j GraphQL API using the Neo4j GraphQL library. But this is not actually working because it's pointed not to our Neo4j or instance that we created. These may be blank, or you may see some old credentials in here. So what we want to do is replace these values in this .env file. So what's going on here is we are setting some environment variables. In this case, Neo4j URI, Neo4j user, and Neo4j password. And then we're reading those environment variables when we construct the driver instance. So if we look at index.js in this Codesandbox link, it looks like Alex dropped that in the chat. So you can just click on that if you don't have the slides open. It's the link that starts with codesandbox.io. This should look pretty similar to the quick start example that we saw a moment ago, with maybe a couple of things added. But basically, we're pulling in the Neo4j GraphQL library, we're pulling in Apollo server, we're pulling in the Neo4j JavaScript driver. Then we have some utilities here for like reading from the file system and pulling in environment variables. But basically, we're loading our type definitions from this schema.graphql file, which is here. And here you can see we have type definitions that match a bookstore API. So we have orders and customers and books and reviews. We'll talk about this in a bit more detail in a moment. But then we're passing this to the constructor for the Neo4j GraphQL library, creating a driver instance to connect to Neo4j. And this is where we're reading these environment variables. So the Neo4j URI, password, and Neo4j user. Then we're passing that schema to Apollo server and starting a GraphQL API. And here we see GraphQL Playground. So what we need to do is edit this .env file to connect to our Aura instance. So the first thing I'm going to do is fork my Codesandbox so that I will be able to edit it. And I can do that just by going, making a change and going to File, Save. And we can see we'll get a note here that we've the sandbox, and now it has a different URL. So now this code's now private to me, only I can edit it. We're just using that skeleton as kind of a starting point. You may need to sign in to Codesandbox. You can sign in with, I think, GitHub and different social sign-ins as well. So you may need to sign in just so that you have access, and you're the only one that has access to this Codesandbox, because you are going to point it at your private Neo4j instance. So you can see right away that I have an error because I don't have the correct values here for Neo4j. So what I'm going to do is go into Neo4j Aura console and see here where it says connection URI. So this is the string that I use with any of the Neo4j drivers to create a connection to this Aura instance. So Neo4j plus S, etc. So I'm going to copy that and paste that in the Neo4j URI environment variable, and then go find where I saved the password from when I first started up my Aura instance. And then I'm going to go here to File, Save, and that will restart my application. I might need to refresh this little browser, but now I should see Codesandbox. And the test here is basically, can I write just a basic query? It's just query for all books and title. And I should see some things logged in the console, and I should see an empty array of books. I'm trying to zoom in a little bit here. So I should see something like this. I should not see an error. And what this means is that it was able to connect to my Aura instance, was able to run a query to search for books and their title. Of course, we didn't get any books because our database is empty, but we didn't get an error. So we're able to connect to our Aura instance. So let's pause for a couple minutes. Everyone should open up this Codesandbox link and update the .env file with the values for connecting to your Neo4j Aura instance, and then try to run this simple GraphQL query. You should see an empty array as the result, but no error message. And remember, you'll need to fork your sandbox once you make the changes by going here to File, Save, which will make it private to you. Cool. So we'll pause for just a minute. If you get stuck on anything, let us know in the chat. We'll pause for just a minute for everyone to get that set up. Then we will take a deeper look at the code to see what's going on there and make some changes.
Cool, super, Will. I saw one question which might have come up for a couple of other people as well. Is or maybe rather, is GraphQL replacing Cipher? Or maybe point out quickly the differences between what would you do with Cipher and what would you do with GraphQL?
Yeah, that's a really good question. I think, let me go back to maybe this slide, which is a good visual aid to think about this. So we said that GraphQL is fundamentally this API query language. So if we think of the benefits that we have with GraphQL, is that we have a strict type system. We can see exactly the data that's available. We can introspect the API to sort of construct type safe clients for it and this sort of thing. And that's what GraphQL was designed for. GraphQL is not designed to be a database query language. And in a database query language, we often want very different functionality from what we want in an API query language. So for example, in a database query language, specifically a graph database query language like Cipher, we want to not only be able to express traversals through the graph, like what we can do with GraphQL, but we also want to be able to do things like aggregations, projections, complex operations that we wouldn't necessarily want to expose at the API layer. We don't often just want to expose our database endpoints and open that up for anyone to sort of work with. What we want to do is build this API layer that has our custom logic defined and that has maybe our authorization implemented, some configuration as well for kind of exactly what we're exposing. So GraphQL is definitely not replacing Cipher in this case. Cipher is not something we're exposing to, in this case, the end user of our GraphQL API is like a React application or a mobile device that we wouldn't want querying our database directly. Instead, we do that by building this intermediate API layer. Yeah, that's a really, really good point that can come up.
Cool. Thanks, Will. And I think that's all I had from the audience.
Okay, great. Okay, well, let's move on. Hopefully everyone got their code sandbox set up by updating the .env file. And again, if you have an error or something didn't quite work out, let us know in the chat and we'll try to get that figured out. But the slides also, if you missed the provisioning your Aura step, you can follow the slides here to provision your Aura instance, and then you can see where in the .env file and in Codesandbox we update those values with the connection credentials for our Aura instance. So as we were looking at the code in Codesandbox, we saw that we had the schema.graphql file, and we had some types declared there. Let's take a deeper look at what's going on there. So we were talking earlier about the graph data modeling process, how we go from business requirements to our graph model. And we can create those visually. There's a great tool called Arrows. Let's just open that up, arrows.app. And Arrows is quite nice. Let's see, do we have, here's a similar one. Arrows is quite nice. It allows us to diagram our graph model. This isn't quite the model we're working with, but it's somewhat similar. And we can see here how we can construct our model. We can edit this. We can set the label on node. So here's a node with the label user and setting the property values. We can create new nodes. So maybe this user wrote a review. So you can see we can create these diagrams, and it's quite nice. We can export like the JSON markup. We want to check that into version control for these models, which is quite nice. And then we can also generate GraphQL type definitions. I need to specify at least one property on this one. Let's try that again. There we go. So we can use arrows to generate these GraphQL type definitions for us just from the visual model. So we would basically diagram our model, and then we can just copy and paste these and drop those into our Neo4j GraphQL library to then build our GraphQL API. Anyway, that's an aside. Arrows is a very useful tool. Let's talk about what these type definitions are saying and how we got to this point. So we went through this graph data modeling exercise and we said, okay, this is how we want to model books and authors and orders and customers. And our GraphQL type definitions are defining that data model using GraphQL. So we're defining an order type, we're defining the fields on the order. So order has an order ID, it was placed at a time, it has a shipping cost, and then it's connected to other nodes, to other types in the data model as well. So we have a ship to, which is an address node. We have a customer, which is a customer node. And these are relationships to those types in the GraphQL type definitions. So you'll notice we're using a few schema directives here to create our type definitions. We just touched on the concept of schema directives earlier at a high level, and we said that that is GraphQL's built-in extension mechanism. Let's look at a few of the directives we're using here. So the one we're using most frequently is relationship, and where it says like at relationship, for example, on the ship to field on the order type, connecting the address to the order. And the relationship directive takes a type argument and a direction argument. So the property graph model that we use with Neo4j, every relationship has a direction and a named type. Relationships in GraphQL don't necessarily have direction, and we don't necessarily want to use the field name for the relationship type, since we typically have different convention for how we name things. So that's the reason the relationship directive exists, is so we can attach this additional kind of metadata for the data model to our GraphQL type defs. The other directives that we're using, one is the ID directive. So here, every order has an order ID, and we don't want our client to have to like generate a random UUID on the client side when it creates an order for the order. Instead, we want that to be generated on the server. So this ID directive does a couple of things. One is it says, well, this field is going to be the unique identifier for order. And then in a mutation, when we create this order, let's not force the client to specify a value for order ID. Let's just generate that in the database and save that in the database, so the client doesn't have to think about specifying that, which is quite nice. I think we do that for order and maybe for review as well, maybe just order. Then we also are using the timestamp directive here, and that is a similar concept. So we're saying in this case for placed at on order and for the created at field on the review, when those nodes are created or updated, we'll update the placed at or created at property in the database. So the client doesn't have to send the date that the order was created. That'll just be set for us server side. There are a lot more directives that are available with the Neo4j GraphQL library that are linked in the docs here. So we can see, think of these as a way for us to configure our API from within the type definitions. The two directives that we'll talk about in more detail are Cipher, which we said will allow us to attach custom logic to our schema. And we will also look at the Auth directive, which allows us to add authorization rules to our schema. So I think those are two of the most powerful GraphQL schema directives. Okay, so let's take a look at actually creating some data using, in this case, GraphQL mutations. So I'm going to go to my Codesandbox and let's try to make this as large as possible. You can also copy this URL and open this in a different tab. I'm going to do it in here so that I can see some of the console output. What we want to do is write a GraphQL mutation to create some data. So if we look in the docs, we see the query fields that have been generated for us, but we also have generated mutations. So we have create, update, delete mutations generated for each operation, or for each type rather. And so what we want to do, let's create a book. So we're going to say, first of all, this is going to be a mutation, and specifically the create books mutation. And create books takes an input object, and the input object matches the fields that we declared on the book type. So we have an ISBN, which is like the book number, the book ID, something like that. So we'll set that value. We'll set the title. This will be the graph algorithms book. We'll set a price for that. And a description. Spark in Neo4j. And then in our selection set, we can see the books that we created. So let's grab title, ISBN, price, and description. So we'll run this and we get back book that we created. Okay, great. We can jump over to our Aura instance. Let's open this in Neo4j Browser. I'll need my password that I saved over here. So Neo4j Browser, if you haven't seen this before, Neo4j Browser is like a query workbench for Neo4j. So I write Cipher queries and I can visualize the results. This is kind of the primary way as you're developing, I think, that you initially interact with Neo4j. So I come over here and I see that, oh, I have a single node in the database, which is this book, Graph Algorithms for 3748 that we just created using that GraphQL mutation. But it's quite lonely. It's just a single node here. So let's write another mutation to, in this case, let's add a review. And review is going to take an input object as well. So we'll give it a rating. This is definitely a 5-star book. If you've read this, we'll write some text for the review. And then now we need to connect this review node that we're creating to the book the book node that we've created. And there are a few different ways to do this. If we add our book field to the input here, we can see that we have two options. We can create a new book node, or we can connect to an already existing book node. So we're going to connect where the node values. Now we're going to filter on some node values for this book that we just added. And I'm going to do this by title because I just typed in a random ISBN. I don't know if that's actually the real one. I'm going to say connect this review node that we're just creating to a book where the title is Graph Algorithms. And then in our selection set, we will also get back the reviews that we created. Let's get back the rating, and let's also bring back the book. Make sure that it's connected to the book that we want it to be. And comes back and says, yep, here's this review that we created, 5-star rating for the book Graph Algorithms. And if we go into Neo4j Browser, not this one, it's a different one, and double click on our Graph Algorithms node, yep, we are connected now to a review node connected to the Graph Algorithms book. And that's kind of what we're walking through in these slides. So in the slides, you can see an example. This is the pattern. This is what we're creating in the graph. One thing that's neat, if we look at our review node in the database, we can see that it has a created date time timestamp associated with it. And we didn't have to specify this in the mutation that we wrote. Where's our mutation? Here's the mutation we wrote. We didn't have to specify the time that we created that order or created that review because we're using the timestamp schema directive for the created at field, so that is set for us automatically, which is quite nice. So this idea of connecting or creating in a mutation, this is idea of nested mutations where we can do multiple operations in a single mutation operation. So for example, I'll just copy this one since it's a little bit long. Drag this out. So I'm going to paste in pretty big mutation operation here. So we're going to create customers. In this case, we're creating customer email ifrom7474 is his username. We're adding some reviews for the user. Then we are creating some orders for this user. We're adding books to the order, and we're creating an address node and connecting that to the order. So we're doing all of these operations in a single mutation, which is quite powerful. So now if we go to Neo4j Browser, we should be able to see now we've created an order for this user that contains this book and is shipping to this address. Cool, so that's a look at the generated mutation functionality. If you were following along, let's delete what we have in our database and start over. So this match A, detach delete A, this is a Cipher statement that will match on everything in the database and then delete everything. So make sure you're in the right database and you actually want to delete what you have in that database. I like to just check and make sure that this data model is the one I'm expecting before we run that. Okay, so now, so we cleared out the database. I'm gonna copy this much larger mutation. So this is what's on slide 40. So I'm gonna run this mutation in GraphQL Playground running in Codesandbox. And this is gonna load the sample data that we want to work with for next module. And if I go into Neo4j Browser, I can see I have 11 nodes and I can see how they're connected. So I have a couple of orders, I have a couple of users, written a couple of reviews, placed a couple of orders for some books that are shipping to a couple of different addresses. So that's what we've created. Let's now talk a bit about the query functionality that we have available with the Neo4j GraphQL library. So we looked at the mutation operations that are generated for creating data. We saw how the input object is generated for those, how we have, it's really a nested structure of operations that we can create with those mutations to create fairly complex subgraphs. So we've created this fairly complex subgraph of users and books and orders and addresses. And now we're going to write some queries that our application might use for, if you think of the functionality for a online bookstore. So the first thing to point out is that we are generating a query field, so an entry point into the API for each type that we defined in our type definitions. So we can start querying for books, users, orders, and so on. And each type that we define is mapped to a node label in the database. So in Neo4j, in this property graph model that we use, every node has at least one label. It's kind of like a way to group nodes. Think of labels as kind of like tables from the relational world, just a way to sort of identify the type of the thing and how nodes are grouped. But each type that we define in our GraphQL type definitions maps to a node label. Then all fields of the type are available in the GraphQL API. We can, of course, configure these. We use directives to indicate which fields we may want to exclude. For sorting and pagination, we can do this offset-based pagination. We saw some of this when we were looking at the movies GraphQL API, where we had the ability to sort and take slices. So just give me the first 10, order by title, that kind of thing. So this allows us to do offset-based pagination. We can also do cursor-based pagination with the Neo4j GraphQL library. So for example, if we had, in this example, lots of books in a single order, we may want to paginate through all those books connected to that order using a cursor. Neo4j GraphQL library supports relay style cursor pagination. This is the relay connection model, I think is what the specification is called, which basically introduces the concept of a connection type that allows us to work with metadata about our relationships in a specific type in GraphQL. That sounds a little overwhelming. It's not too bad. You can sort of see what that looks like in this example for grabbing the cursor and then paginating through those connections. There's a lot more information in the documentation for this as well. So filtering is important functionality that is generated for us. So filtering is available through the where field argument. And there are lots of different comparison operators that are generated depending on the type of the field. So for example, for numeric values, we can do greater than, less than, those sorts of comparisons. For string fields, we can do string comparison operations like starts with, contains, ends with, those sorts of things. We can also apply these filters in a nested manner. So here we're filtering for books that have a price of less than $20. And then for all of those books, filtering for reviews that were created after a certain date. Note though that the filter is applied at the level in the selection set where I attach it. So because I'm filtering for reviews that were created after some date and I'm applying that at the reviews level, that filter is not applied to the books. So I'm still getting all of the books that have a price under $20, regardless of whether or not they have reviews that were created after a certain date. So the filtering is applied at the level of the selection where you use it in the where argument. We also, for point fields, also expose filtering by distance. So here we're searching for addresses that are within a kilometer of a certain latitude and longitude, which is quite useful for any applications that are working with geodata. So I just said that these filters are applied at the level where we use them in the selection sets. But what if I want to sort of filter through relationships? So what if I, in this case, I want to filter for all orders that are being shipped to an address within a kilometer of a certain point. So it's not enough that I'm filtering for the addresses. I also want this filter to be applied at the order level. So to do this, I just use kind of a nested structure in the where argument, but I use the where argument in this case at the root, at the orders field, so that our filter is applied to the order, basically at the root of our query. Okay, great. So that was a look at the mutation functionality and the generated query functionality that we get with the Neo4j GraphQL library. Let's pause here for another exercise. So what we want to do now is take a look at the GraphQL schema that is included in the Codesandbox example that we're working with. And we can see that it's missing a couple of things. We're missing author and we're missing subject, like the topic of the book. So your exercise for this one is to update the schema.graphql file to add the author and the subject types to our GraphQL schema. So you're going to edit schema.graphql to do that. And then once we've done that, we want to write GraphQL mutations that would add authors and subjects to the graph according to these tables. So we have 3 books that we've added to our database. We need to add their authors and then also the subjects for each of those. If you get stuck, this link has the solutions in the README. So you can take a look at that. But definitely give it a try. So again, here's Codesandbox. What we want to do is edit schema.graphql to include authors and subjects, and then connect those to their books using these 2 tables. So we'll pause here for a few minutes, and then we'll take a look at the solution for that before we move on to the next section. So the next section is dealing with custom logic using Cipher. So we'll pause here for a few minutes, and again, ask in the chat if you run into any issues or have any questions.
Cool. Thanks, Will. No particular question came up in the meantime. A couple very specific ones. I think we probably keep keep in chat. But we answered those. No problem. Maybe while the more experienced people try it out for anybody else, what would be a good way to start learning? If you hear about this all and think, hey, this is cool, I wanna get into it, I wanna take a next step, or like maybe even a first step, even with GraphQL and Neo4j. Anything you can recommend?
Yeah, I think certainly it depends on your learning modalities, I guess, and everyone learns in different ways. I know for me, I like to just get hands-on building something and break something and figure out how to fix it, essentially. So I'd say for me, probably I would start with maybe Neo4j Sandbox. So one thing that's neat about Neo4j Sandbox is that we have lots of different data sets that I can start with. So I don't have to think about, okay, what's an interesting data set? Where's the data for it? How do I load it? This kind of thing. I have a bunch of different things loaded. We have the canonical movies example, but also things like data from OpenStreetMap. I can connect my Twitter data, looking at generating recommendations, these kinds of things. And all of these, I spin one up here. You can see what this looks like, but these have GraphQL code snippets and schemas associated with them. So what's cool is I can spin this up and I can go into the language tab, and I can see here's a GraphQL schema. This one actually, this is OpenStreetMap data. So there's a bunch of things in here for using the routing functionality like Dijkstra algorithm and A-star algorithm from graph data science that are exposed through GraphQL. So I would just start up one of these, pull down the sample code for the GraphQL API and see how it works and tweak some things and just sort of go from there. There's lots of different resources. I mentioned the online training as well. We do some things on the live stream as well to build these kind of sample apps. But yeah, I would say probably just checking out Neo4j Sandbox, check out the different example data sets and sort of see what piques my interest is probably where I would go.
Cool. Thanks. Yeah, just Wayne commented on it as well, and he's done some he's worked with the Twitter database or Sandbox example and used GraphQL to connect to the front end, and now he's using this and Neo4j for everything. So I think learning curve isn't too steep, so it goes quickly.
For sure. Yeah, that's great to hear. Yeah, and there's also on GitHub the Neo4j Graph Examples GitHub organization, which has the data sets and code samples for all the Sandbox data sets. So when you mentioned Twitter, I think there's a GraphQL API for Twitter in here. Yeah, so this is what you get. You can either connect your own Twitter accounts and your data gets pulled into Sandbox, and then you can use this example to build a GraphQL API using your own Twitter data, which I think is pretty cool. Or there's also, I think, a hosted endpoint for this? Oh, there's a Codesandbox for it, so you can pull that into Codesandbox. Jennifer was working on this and built a retool dashboard that uses this GraphQL endpoint. So retool is like this low code UI builder that works with GraphQL. So she built a sort of a Twitter app pointed at the Neo4j Twitter data through GraphQL, which was pretty neat.
Super. Thanks, Will. And I think that is that's all from the question side.
Okay, great. Well, let's move on. So we have 20 minutes, and we have 2 more modules. So maybe I will just talk about the solution to this, and then we will talk through the other 2 modules and maybe leave some of the assignments for you to do at home. But basically, what we needed to do in this one for updating our GraphQL schema, let's just take a look at the solutions. So this link is actually opening up another Codesandbox. I just wanted to read the README. So what we want to do here is update our GraphQL type definitions to include author and subject. So let's just copy paste these. So we're adding an author type and a subject type, and then we're connecting author to books with a relationship directive, and we're connecting subject to books also. So we're saying that an author is an author of a book, and a book is out a subject. We also want to update the book type to say authors, and we can have 1 or more authors. So that is a array field, and this will be relationship. Type we set is what, author of the book. So in this case, the direction is going to be in. So I'm incoming to the book and the author of the book. And then what else do we want on here? Maybe let's call this subjects, which is going to be an array of subject objects. And we said what the book is about a subject. So the direction is going to be out. And that these fields match sort of the other end of these relationships, if you want to think of it that way, why we added both those there. Okay, so we'll save that, and that will that restart? Yeah, so that restarts our API. So now to create authors connected to their books, let's copy this mutation. Since we're a little short on time, we'll just copy this and go over here to Graphql Playground. And let's look at what we're doing. So we are running a create authors. And oh, it doesn't like this. Maybe we need to refresh to get our new types. Yeah, there we go. So we are creating authors and we are connecting them to our books. I think this is slightly outdated syntax as well. I think we need to add an intermediate node here. Yeah, so the reason for that is with the additions to the Neo4j GraphQL library to support connection types, we introduce the additional node object here because we could be filtering on either node or edge values here. Okay, so we're creating authors. So we have 1, 2, 3, 4 authors here. And then we are connecting, so using the connect functionality to connect the author to their book, filtering by title. Cool, you see we've created that in the graph, and then we need to do something very similar for our subjects. And in this case, what we do is we do an update operation on the books. We could start from creating the subjects then connecting to the books, but in this case, we update the book, filter by title, and then instead of a connect, we do a create operation for subjects, which is going to add the subject nodes and connect those to our books. Cool, so that is the exercise. Let's move on since we're running a little short on time and talk about adding custom logic. So I'm going to clear out the database and we're going to start a new code sandbox. The reason we're starting a new code sandbox is this one has the authors and subjects and also has some additional custom logic things that we've added. So let's copy our .env file with my Aura credentials and paste that in here to replace the values in this code sandbox. So now I'm connected to Aura. And if we look at, so here's our new sandbox. If we look at Schema, we'll see quite a few Cipher directive fields in here, as well as new types like weather and some custom mutations and a custom query field. So you can see what we're going to build up here just by looking at the schema, but let's talk through it. So there are two basic approaches to adding custom logic in our GraphQL API with the Neo4j GraphQL library, we can use these Cipher directive fields that we've mentioned a couple times, where we're attaching a Cipher statement to our API, or we can implement custom resolvers. So these are functions we're going to write that have some custom logic that could really do anything we want. We could connect to Neo4j, write a query, we could call out to some other system, we could read from the file system. Like the sky is the limit. If we can write code for it, we can do it in a resolver. But let's talk about the Cipher schema directive. We can use these to compute computed scalar fields. So here on the order, we may want to calculate the subtotal. And here we're just looking at the sum of the price of all the books in an order. But this may be more complex. We may have discounts specific to the user. We may have other various prices for the book. Maybe if you buy 10, you get a discount or something like that. So we may have some more complex logic for calculating the subtotal, and we want to be able to express that in Cipher. So we write a Cipher statement and we attach that to the GraphQL schema in the type definitions with this Cipher schema directive. So now when we request the subtotal field on the order type, rather than going to the database and trying to fetch a subtotal property off of an order node, instead we'll run this Cipher statement to compute that value. And here we're using this extend keyword to add this field. We could also just add this field on the order type. Extend is nice because if I have multiple files with my type defs that I'm combining together, I can have all my extensions in one, or however we want to structure it. I think it's a handy feature. So now at query time, to the client of the GraphQL API, to them, they don't see that this is a Cipher directive field. It's just another field in the GraphQL API. We can also return node and object fields. So here we are finding personalized recommendations for a specific user using a collaborative filtering query in Cipher. So this is for a customer looking at what books they've ordered and other users that have ordered the same books that this user has not ordered. Those might be good recommendations. So previously we were returning a scalar value. We can return nodes from our Cipher queries in the Cipher schema directive that map to our GraphQL type system. In this case, we are returning book nodes. And again, similarly, this recommended field shows just another field of, it's an array of books. Any field arguments that we define on these Cipher directive fields are passed into the Cipher statement as Cipher parameters. So here we are defining a limit field argument on this recommended field with a default value of 3. I like to use default values here because then we don't have to think about what to do in the Cipher statement if the user didn't provide a value. We know we're always going to get an integer value of 3 by default. But here, this limit value is passed into this Cipher statement as this Cipher parameter limit, which is just quite nice. We can also return sort of projected objects from our Cipher query. So returning maps or dictionaries, returning an object that maps to a type that we've defined in the GraphQL type definitions. This doesn't need to map to types that exist in the database. So for example, here we've added a weather type that has things like temperature, wind speed, precipitation. that we're fetching from some external API. We're doing this all using Cipher, using APOC load JSON, which if you're not familiar with APOC, APOC is the standard library for Neo4j that extends Cipher with some functionality. So here we're calling out to another API to fetch weather data for, in this case, this is for our delivery drivers to know for the addresses the orders are going to, what the weather is going to be like. And we don't have this weather node in our database. This is just being returned as a projected object from this Cipher query. But now we add that to our schema, and now we have this current weather field connected to our address node. So we can see what the weather is going to be like as we're planning our deliveries. We can also use these Cipher directive fields at the root, so as query or mutation fields. One case is maybe for full text indexes. So if I want to be able to do fuzzy matching or something like that, I could expose full text querying functionality through a query field. And similar for mutations if we have some custom mutation logic. So that's the Cipher schema directive. Implementing custom resolvers, we simply define the relevant types and fields in our type definitions, and we can use the ignore directive to say, hey, Neo4j GraphQL library, don't try to fetch this data from the database in your generated Cipher query. Instead, just call the resolver function. And then it's up to us to implement whatever logic we want in that resolver function. In this case, we're estimating a delivery date just by generating some random time in the future. But you can imagine we call out to a logistics system or something like that to get a more real world delivery estimate. Hopefully this is not what our online commerce stores are doing to us. Cool. So so there's an exercise here to take a look at the similar field. So if we take a look at our Codesandbox GraphQL schema, we can see that all of the Cipher directives examples that we looked at have been added here. So we have subtotal, shipping cost, we have calling out to fetching weather, we have some personalized recommendation queries, that sort of thing. So the exercise here is to tweak that recommendation query using Cipher. But instead, we have 5 minutes left. So let's skip that. And instead, let's talk a little bit about how we handle authorization with the Neo4j GraphQL library in the time we have remaining. So oftentimes we need to add fine-grained authorization rules at the API level to sort of handle what data and operations we should expose to application users. And the Neo4j GraphQL library has a ton of functionality for this that is encapsulated in the Auth GraphQL schema directive. The Auth directive allows us to add these authorization rules and then uses a JSON web token to basically determine if the authenticated user has the permissions that match the rules that we have defined in the Auth directive. So JSON Web Tokens, if you're not familiar with these, JSON Web Tokens are basically like signed JSON payloads, I guess is a way to think of them. So we have some, they're called claims in the token that say like, this is my username, this is my email, this is my role, whatever. And that token is generated by the application and then signed by the application. So we can verify that the user is sending a valid token if it was signed using the correct key or not. So anyone can read a JSON Web Token. It's just whether or not it can be verified. That's the important piece. So you can see here the payload that we have a subclaim, which is the subscriber, which is typically like the username or user ID in a token. And then we also have roles, and this user is claiming to be an admin. So what are some rules that we can define with the auth directive? Well, the simplest one is just to say that the user is authenticated. So in this case, they need to be sending a valid JSON Web Token that is signed by our application in order to, in this case, see the subject. So imagine we have a basic search page for books, and you can search for basic information. If you want to see like the subject, the topics of the book, well, then you need to sign into my application to see that as like a premium feature. So this is what it looks like if I request a field that I need to be authenticated to see. I get an error. We can also attach roles. So we can say that in order to create, read, update, delete a book, then you need to be an admin role, for example. Allow is a bit more powerful than role because it's actually verifying that data in the database matches data from the JSON Web Token. So here we're saying that a customer can only see their orders when the sub claim, so when the subscriber of the token matches the customer username. So only show orders that are connected to the currently authenticated user, basically. And then I can combine these, so I can say either the currently authenticated user, or if you're an admin, you can see orders as well. The where rule is similar to allow, but this will actually add predicates to the generated database query. So I don't need to filter in the GraphQL query for orders for the specific user. The user can request what they want, and they'll only see what they have access to. So for example, this is saying that only the currently authenticated customer can see their own customer information. So I can ask for all customers, but I'm only going to get my customer details. Bind is a rule that allows us to, when we're creating data, ensure that it matches some pattern in the database. So for example, this rule is saying when we're creating or updating an order, or a review rather, that the author of the review needs to be the currently authenticated user. So only users can create or update their own reviews. So those are some of the basic rules that I can define using the auth directive. It's super powerful. There's also the ability to use it on the Cipher directive fields. And here we're checking that the user is authenticated to use this field, but then also we can access the JWT token in the Cipher statement. So here we're saying auth.jwt.sub to look up the customer. So this is a Cipher query to generate personalized recommendations for the currently authenticated user. And we just grab the username from the JSON Web Token that's injected into the Cipher statement in this auth.jwt Cipher parameter, which is really cool, because then that means we can say like just have a query that says books for current user, where we're showing the currently authenticated user, wherever they are, some book recommendations, which is really cool. So there's some associated exercises here to create a new user and create a new token for them. But we are out of time for today, so we'll leave that as an exercise for doing on your own, I suppose. There are also a lot of features that we didn't have a chance to talk about today, things like working with unions and interfaces, relationship properties. There's an OGM based on your GraphQL type definitions as well. OGM, if you're not familiar, are like object relational mappers, but use object graph mappers using your GraphQL type definition. So the idea here is you write GraphQL type definitions, and then I get a type-safe API for querying the database in my application. So lots of really interesting aspects of Neo4j and GraphQL that we didn't touch on today. There's more in the Graph Academy training, which is the 4th bullet point here. It uses a similar data model to what we built today, but has a bit more detail and is self-paced. There's also the documentation and the library overview page, I would say, are good places to go next to sort of see in a lot more detail some of the things that we didn't cover today. But I guess we are out of time. So thanks everyone for joining today.
Cool. Thank you very much, Will, for guiding us through and for showing us the GraphQL library. Thank you all for joining and for participating. Thanks for your questions. As I said in the beginning, we will share the video and the deck with you all, so you can, like Will just said, you can try to follow the steps on your time by yourself, or you can use the links here that go further into the details of documentations and also further training sessions. So that's, I think, a next step. If you are interested in learning more, we will be back next week with another training session. This time it will cover knowledge graphs with our colleague Claire. So that's something to look forward to. I think I will post the link in chat if you want to register for that. So here you go. Yeah, with that, I hope you had a good time. I hope it was worth your while. Thank you again, Will, for presenting and for showing. Hope to see you again in another session sometime. And thank you all for joining.
For sure. Cheers, folks.
Thank you. Bye.